Hello everyone, I am Giray Altuğ Korkmaz. Today we will discuss with you one of the most fundamental and frequently studying or encountered topics in computer science and data structures, both in terms of algorithm and software development, converting infix expressions to postfix form and calculating postfix expressions. And in this topic, we will make use of the stack data structure that is readily available in the Java programming language. And stacks work on the last in, first out principle and is an indispensable structure to maintain the order of operators and operands in mathematical expression analysis algorithm. And in this homework, we have two statements, infix and postfix. Infix expressions written as we are used to in mathematics, a plus b multiplying by c, a format difficult to be solved directly by computers, and postfix, a format that computers can easily understand, whose order of operations is error-free and written without the use of parentheses, A, B, C, multiplying, plus. And in this application, we will develop an algorithm to convert an infix expression into postfix format. In this process, operator precedence and parentheses balance will be preserved thanks to Java stack class, and we will compute or calculate the postfix expression using stack thanks to the postfix form. The order of operations will be solved with the help of the stack without errors. To make our code more professional and readable, we divided it into three separate classes. In this way, we created a modular, clean, and easy to maintain project structure. And this project will both improve your algorithm logic and show you the practice of modular programming that you will encounter in real-life software projects. And let's evaluating the code. And first of all, we have importing sentences. Import java.util.stack. We include the stack class from the Java util package. This class works on the last in, first out principle, as I told you in the beginning. This class works on the last in, first out principle, where the last item added is the first to be removed. This structure is commonly used to manage operators and parentheses in mathematical expressions. And after that, we have public class, and I called my class infix to postfix converter. This line marks the beginning of a Java class. The infix to postfix converter class is specifically responsible for converting an infix expressions to a postfix expressions, as you see in the name. And public string convert, and we have a parameter string type expressions. And this method takes an infix expressions and returns its postfix equivalent as a string. The expression parameter represents the mathematical expressions provided by the user. And string results, we define an empty string, this name is results, to store the final postfix expressions. Characters will be added to it step by step in the correct order. And after that, we have stack character. in the stack form character, we called this is stack, and we have creating a new stack. A stack object is created to temporarily hold the operators and parentheses, and these characters will be processed according to their precedence, ensuring that the correct postfix expression is formed. And we have a for loop, and this for loop processes each character in the provided expressions one by one. The toChar array method converts the string into a character array, and we have if statement. If character that is letter or digit is in the parameter C, and result added by C. If the character is a letter or a digit, it is directly added to the result string. Operand characters, number or variables, doesn't matter, don't need any rearrangement. And we have else if statement, an opening parenthesis, as you see in my cursor, and is pushed onto the stack. Parentheses control the precedence of operations, so they are temporarily stored, yeah, until the closing parenthesis is encountered. And we have another else if statement, but in this case we have while loop in it, and when a closing parenthesis is encountered, operators are popped from the stack and added to result until an operating parenthesis is found. The operating parenthesis is then removed from the stack as it is no longer needed. And we have another while method outside the else. If the in this mean, if the character is an operator, we compare its precedence with the operator at the top of the stack. If the top operator has higher or equal precedence, this is the control mechanism, and it is popped and added to result. And then the current operator is pushed onto the stack. We are pushing after this process, and we have another while loop, and once the expression is fully processed, any remaining operators in the stack are popped and added to the results, completing the postfix expressions, and the result string is returned as the postfix expressions. Sorry. And we have a private integer precedence. We have parameter in it, char. We call this is C and hash, and these sentences mention us a helper method that determines the precedence of operators. It tells us which operation should be performed first, and after that we have if, else if, and else statements. And the mathematical precedence of operator is plus and minus equals to 1. 1 is the lowest precedence. Multiplying and division is equals to 2. 2 is the medium precedence, and power symbol is 3. 3 is the highest precedence, and this class evaluation is over. Let's take a look the postfix evaluator.java, and we have also import Java util stack, and the stack class is imported. It will be used for temporarily hold operands while evaluating the postfix expressions, and we called our class is postfix evaluator. This is a Java class designed to evaluate the postfix expressions, and we have public int evaluate, and we have parameter string form, and this name is expression. This method takes a postfix expression as input and returns the result as an integer. Sorry. And we have a stack integer stack, and we are creating the new stack. A stack of integer is created to temporarily hold the operands while evaluating the postfix expressions. And we have for loop, and a for loop iterates through each character of the postfix expressions, and we have if statement, if character that is digit in C or for by the parameters, and stack that push C minus string 0. If the character is a digit, its actual integer value is obtained by subtracting this string 0 or the ASCII value of 0, sorry, and the number is then pushed onto the stack. And in the else method, we have two value val2 and val1, and if the character is an operator, two operands are popped from the stack. These operands are used to perform the operation, and if C equals plus stack that push val1 plus val2, and we have after this if statement, we have three else if statement. In the total of the if and else if statements, based on the operator, the corresponding arithmetic operation is performed, and the result is pushed back onto the stack. And after that, after the expression is fully processed, the final result is the only element left in the stack, and it is returned. And we are done for the postfix evaluator, and we have final class which name is main, and I used this class for the testing the conversion examples. And in the beginning of the code, in the previous of the studying of the data structures, the main class where the program execution begins. This class is responsible for testing and displaying results, and we are main method, the main method where the Java program is executed, and we have to create the object, and an object of the infix to postfix converter class is created to convert infix expressions to postfix, and we have creating a new class, new object, sorry, and this is our first example. The first example, the expression a plus b multiplying by c is converted into postfix, and the result is printed. And The second example, the expression a plus b in the parentheses multiplying by in the parentheses c plus d and is converted into postfix, and we have also creating a object postfix evaluator class is created to evaluate postfix expressions. We have to create an object for postfix and infix by the examples. And in the our first postfix example, and the result of the first postfix expressions, 23 multiplied by 4 plus is calculated and printed, and in our second postfix expression, and 52 plus 83 minus multiplying by 4 and division symbol is calculated and printed, and it's over. And this is the output of the our test class. We evaluated the three classes, and in today's lesson we converted infix expressions to postfix format, which is easier for computers to process. And we evaluate postfix expressions step by step using a stack. Sorry. We learned how to use the stack data structure in Java and how it can be applied to solve mathematical expressions. And by splitting our code into three distinct classes, we gained practice in writing modular code and learned algorithmic logic in practice. And thank you for listening and watching me. See you on the next examples and homework. See you.